The warning lights flashed across the bridge of the luminous thought as the sensors detected something impossible. Chief Scientist Keleth 9 stared at the display with all three of his optical organs, trying to make sense of what he was seeing. "That cannot be correct," he said, his translator converting his clicks and whistles into standard concordant language. "Run the diagnostics again." His assistant, a young Viridian named Seth 12, worked frantically at her station. "Sir, the diagnostics confirm it. There is a ship ahead. It is using a jump drive, but the energy signature is all wrong." Keleth 9 had been studying physics for 47 standard years. He had 3 doctoral equivalents and had published over 200 papers. Nothing in his extensive education prepared him for this moment. The ship ahead was breaking at least 4 fundamental laws of physics as the Concordat understood them. "Hail them," Captain Velor ordered from the command platform. "Let us see who these mysterious travelers are." The communication system crackled to life. The face that appeared on the screen made everyone on the bridge freeze. It was a bilateral species with 2 forward-facing eyes, a protruding nose structure, and a mouth that curved upward in what their database identified as a smile. "Hello there," the alien said cheerfully. "This is Captain Maria Santos of the Earth vessel Persistence. We come in peace, though I have to say we did not expect to run into anyone else out here." Keleth 9 felt his breathing sacs flutter with excitement and confusion. Earth. The database search returned results immediately. This was humanity, a species that had only achieved faster-than-light travel 50 standard years ago. They were practically children in galactic terms. "This is the Concordat science vessel Luminous Thought," Captain Velor responded. "We are pleased to make contact with you. However, we must ask, how is your ship functioning?" Captain Santos looked puzzled. "Functioning? She is running just fine. All systems green. Why do you ask?" Keleth 9 could not contain himself. "Your fusion drive is operating at 47% efficiency. This is impossible. The theoretical maximum is 31%. Your jump drive signature suggests a power output that should have torn your ship apart, yet you appear completely undamaged." The human captain laughed, a sound that the translator struggled to interpret. "Well, our engineers are pretty good at what they do. Would you like to come aboard? We can discuss it over coffee." 2 hours later, Keleth 9 found himself in the cargo bay of the human ship, and he wished he had stayed on the Luminous Thought. Everything about this vessel was wrong. The walls were covered in pipes and wires that should have been hidden. There were manual valves everywhere, with handwritten labels that said things like "Emergency Override" and "Use only if computer fails." "This is your primary navigation computer?" Keleth 9 asked, pointing at a console that looked like it had been assembled by someone who had never seen a proper computer before. "That is the backup," Captain Santos explained. "The primary is over there, but we always have backups for the backups. And then manual controls if everything else fails." "But why?" Keleth 9 could not understand. Properly designed systems do not fail. Redundancy is inefficient. A human engineer named Rodriguez laughed from where he was working on a power conduit. "You have clearly never had a computer crash during a critical moment. We design for when things go wrong, not if they go wrong." Keleth 9 examined the power systems next. What he found made his teaching glands ache with confusion. The humans had 17 separate power generation systems on a ship that only needed 3. They had cooling systems that could handle 10 times the heat their reactors produced. They had structural supports rated for forces they would never encounter. "This is massive over-engineering," he said to Captain Santos. "Your ship must be incredibly expensive to build." "Actually, it was pretty cheap compared to our military vessels," she replied. "We build things tough. Space is dangerous. Equipment fails. We would rather have too much than too little." The fusion reactor was the worst offender. Calath 9 spent an hour examining it with his scanning equipment. By every calculation he made, this device should not work. The magnetic containment was too simple. The fuel injection system was crude. The cooling mechanism relied on basic heat exchangers instead of advanced quantum cooling. Yet the reactor hummed along smoothly, producing more power than a concordant reactor twice its size. How? Calath 9 finally asked. How does this work? Rodriguez shrugged, a gesture the translator interpreted as uncertainty. It just does. We tested it about 1,000 times before we installed it. It works in normal conditions, cold conditions, hot conditions, high radiation, low radiation. We even tested it after simulated battle damage. As long as the core containment holds, it keeps running. But the mathematics... Look, Doc, Rodriguez interrupted. I do not know all the fancy math. I just know that we built it strong, we built it simple, and we built it to take a beating. That is how we do things. On the way back to the luminous thought, Calath 9 was silent. His mind was racing with possibilities. Either these humans had stumbled onto new physics that the entire Concordat had missed, or there was something fundamentally different about their approach to engineering. That night, he filed his report with the Concordat High Council. He included every scan, every measurement, every impossible reading. He concluded with a single sentence that would change the course of galactic history. We do not understand human engineering, and this may be the most important mystery the Concordat has ever faced. Within days, the Council's response arrived. They were sending the finest scientific minds in the galaxy to investigate. They needed to know how a species so young had built technology that surpassed their own. Calath 9 looked at the human ship one last time before the luminous thought departed. Somewhere in that crude, overbuilt, impossible vessel was an answer that could change everything the Concordat thought they knew about engineering. He intended to find it. The Concordat Central University occupied an entire moon-orbiting Nexus Prime. Its laboratories had produced 90% of the major technological breakthroughs in the galaxy over the past 10,000 years. Now, its greatest minds gathered in Laboratory 7 to solve a puzzle that made no sense. Dr. Thexelon stood before the collection of human technology samples, her crystalline body refracting the laboratory lights into rainbow patterns. She had an intelligence quotient equivalent of 340, making her one of the smartest beings in known space. She had solved problems that others said were impossible, but this was different. Begin with the simplest device, she instructed her team. The human power tool. The tool in question looked like something a primitive civilization might use. It had a handle, a trigger, a rotating bit, and a power cell. The Concordat equivalent could perform the same function with 3 moving parts and a neural interface. The human version had 40 moving parts and required manual operation. Dr. Zixith, a 6-limbed arachnoid engineer, activated the tool. It whirred to life, spinning smoothly. Performance is adequate, he reported. Energy efficiency is 73%. Our tools achieve 91% efficiency. Run the stress test, Thexelon ordered. They subjected the tool to conditions that would destroy most Concordat equipment. Extreme heat, freezing cold, high humidity, dust infiltration, repeated impacts. The human tool kept working. The Concordat equivalent failed after the 3rd test. Impossible, Zixith muttered. The tolerances are too loose. The materials are too simple. It should have failed immediately. But it had not failed. None of the human devices failed. Next, they examined a human computer system. The programming code made Thexelon's processing centers ache. It was messy, inefficient, and full of redundant checks. There were error-catching routines for errors that should never occur. There were backup systems for backup systems. The code was 3 times longer than it needed to be. This is terrible programming, declared Mortalk, the Concordat's finest software architect. I could optimize this down to 1/3 its current size. Do it, Thexilon said. Then test both versions. Mortok spent 6 hours creating a streamlined, elegant version of the human code. It was beautiful. It was efficient. It used advanced algorithms that the humans apparently had never discovered. He ran it through the testing simulator. It performed identically to the human version under normal conditions. Then they introduced errors, a corrupted data packet, a hardware glitch, a power fluctuation. The optimized code crashed. The human code detected the error, routed around it, and continued functioning. They design for failure, Thexilon realized. Every system assumes that something will go wrong. The human representative, a young engineer named Arya Chen, had been watching quietly. She spoke up for the first time. My grandfather was a software engineer. He always said, "It is not a question of if something will fail, but when." That is a very pessimistic view, Mortok said. Arya shook her head. It is a realistic view. Nothing is perfect. Hardware degrades. Software has bugs. Users make mistakes. We build our technology knowing this. The next demonstration nearly caused a diplomatic incident. They were testing thermal management systems. The Concordat device was a masterpiece of quantum engineering, using entangled particles to transfer heat with perfect efficiency. The human device was a simple heat exchanger with coolant pumps. They subjected both to increasing heat levels. The Concordat device worked flawlessly until it reached its design limit, then failed catastrophically, requiring complete replacement. The human device started making warning sounds at 80% capacity, continued functioning less efficiently as heat increased, and even when it finally stopped working, it could be repaired with basic tools in 20 minutes. But our device was superior in every measurable way, protested the engineer who designed it. Except reliability, Arya pointed out, and repairability, and cost, and survivability. The breakthrough came during a meal break. The team was in the cafeteria when Arya pulled out what she called a coffee maker from her personal belongings. It was a small device that heated water and forced it through ground plant matter to produce a stimulant beverage. Humans need this poison to function? Asked Kelath 9, who had joined the investigation team. It is not poison, Arya laughed. It is coffee. We love it. She activated the device. It worked perfectly. Then, accidentally, someone knocked it off the table. It fell 2 meters, hit the floor with a loud crack, and skidded across the room. Arya picked it up, examined it briefly, and turned it on. It still worked. For comparison, Thexilon ordered a Concordat food synthesizer brought in. It cost 16,000 credits and could produce any of 10,000 different dishes with molecular precision. She placed it on the table next to the coffee maker. Now, drop your synthesizer, Arya suggested with a smile. That would be foolish, Thexilon said. It would break. Exactly. The point was made. The team spent the next week testing human durability standards. They discovered that humans designed everything to survive what they called worst-case scenarios. These were situations that the Concordat considered statistically impossible. A human door could withstand a direct impact from a vehicle. A Concordat door would fail if you hit it too hard. Human electronics could function after being soaked in water, dried out, and powered back on. Concordat electronics died permanently if exposed to moisture. Human furniture could support 10 times its rated capacity. Concordat furniture would collapse if overloaded by even 10%. Why do you build everything so strong? Thexilon asked Arya during one of their sessions. Arya thought for a moment. Honestly, I am not entirely sure. It is just how we do things. My engineering professor used to say we design for Murphy's Law. What is Murphy's Law? If something can go wrong, it will go wrong. At the worst possible time. In the worst possible way. Thexilon processed this information. It was such a strange philosophy. The Concordat designed for perfection, for optimal conditions, for ideal circumstances. Humans designed for chaos, for failure, for disaster. And somehow, the human approach worked better in the real universe. "I need to see where this comes from," Thexilon announced to the team. "I need to see Earth. I need to understand how an entire species develops this engineering philosophy." She sent her request to the High Council that evening. She received approval within hours. The Council was as desperate for answers as she was. 3 days later, the research team boarded a fast courier ship bound for Earth. Calath 9, Thexilon, Aria, and a dozen other specialists. They were going to the source, to humanity's home world, to find the answer to the question that had consumed them all. Why did human engineering work when it should not? The research team's first view of Earth from orbit made several members uncomfortable. The planet looked beautiful from space: blue oceans, white clouds, green and brown continents. But the data told a different story. The atmospheric pressure varies by 15% depending on altitude, Calath 9 read from his scanner. Temperature swings from -80 degrees to +60 degrees. Tectonic activity causes massive ground movements. Weather patterns include violent storms with wind speeds exceeding 200 kilometers per hour. "This is classified as a Class 12 death world," Thexilon added, referencing the Concordate planetary database. "The rating system only goes to 15. How did an intelligent species evolve here?" Aria smiled from her seat. "We are tougher than we look." Their shuttle descended toward what Aria called Detroit, a manufacturing center in the North American region. As they approached, the aliens could see massive factory complexes belching smoke and steam into the atmosphere. The environmental conditions looked harsh even from the air. Inside the factory, the conditions were even worse. The temperature was hot enough to make Calath 9's skin uncomfortable. The noise level was painful. Massive machines hammered, pressed, and welded metal with violent force. Sparks flew everywhere. Human workers moved between the machines wearing protective equipment, seemingly unbothered by the chaos. "This is barbaric," whispered Zixith. "Our manufacturing is done in clean rooms by precision nano-assemblers." The factory manager, a woman named Sarah Mitchell, gave them a tour. "This is where we build the hull sections for cargo ships," she explained, shouting over the noise. "Each section gets pressed from a single sheet of steel, reinforced with support beams, then welded together." "Why not use molecular assembly?" Thexilon asked. "It would be more precise." Sarah shrugged. "Costs too much. Takes too long. This method works. These hull sections can take meteor impacts, temperature extremes, and still hold together. We have ships 200 years old still flying cargo routes." The next stop was worse. They visited a power plant where humans generated electricity by boiling water with nuclear reactions, then using the steam to turn massive turbines. The Concordate had abandoned such crude methods thousands of years ago. "But it works," the plant supervisor explained when he saw their shocked expressions. "The reactor can run for 40 years without refueling. The turbines last 30 years between major maintenance. Simple, reliable, effective." Thexilon was beginning to see a pattern. Humans did not pursue elegance. They pursued reliability. They did not optimize for efficiency. They optimized for survival. Their third stop was a small repair shop in rural Montana. An elderly mechanic named Jackson Pierce worked there, fixing everything from farm equipment to spacecraft components. His shop was cluttered with tools, parts, and half-assembled machines. It looked nothing like a proper Concordate research facility. "Tell me, Mr. Pierce," Thexilon said, "why do humans design things the way you do?" Jackson looked up from the engine he was repairing. His hands were covered in grease, and he had a smear of oil across his weathered face. "Well now, that is a big question. I suppose it goes back to how things used to be. My grandfather taught me to fix things. And his grandfather taught him. Goes back thousands of years. He picked up a wrench, an ancient tool that had changed little in centuries. See this? Simple. Reliable. Does one job very well. I could use a fancy electronic tool that does 20 jobs. But what happens when the battery dies? Or it breaks? Or the computer glitches? This wrench will work for another 100 years without any maintenance. But surely efficiency matters, Kelath 9 said. Sure it does. But reliability matters more. Out here, if your equipment fails, you might be hundreds of kilometers from the nearest repair shop. You might be in a blizzard, or a drought, or any of a dozen other problems. So we build things that work even when everything goes wrong. Jackson showed them his current project. It was a quantum computer core from a satellite. According to concordate standards, it was irreparable and should be replaced entirely. Jackson had diagnosed the problem, isolated it to a single failed component, and was in the process of installing a replacement. How did you know which component failed? Thexilon asked. Experience, intuition, and I hit it with a hammer a few times until I figured it out. You hit advanced technology with a hammer? Percussive maintenance, Jackson grinned. Sometimes things just need a good whack to start working again. Don't tell the manufacturers that, though. The team moved on to CERN's successor facility, where humans conducted their most advanced physics research. Here, at least, the aliens expected to find something familiar. They were disappointed. The particle accelerator was enormous, crude by concordate standards, and surrounded by redundant safety systems that seemed excessive. When they asked to see an experiment, the head physicist, Dr. Yuki Tanaka, agreed enthusiastically. Today we are testing a new gravity manipulation system, she explained. We have run the simulations 1,000 times. Today we see if it works in reality. The experiment began. For 3 minutes, everything functioned perfectly. Then there was a flash, a loud bang, and smoke filled the observation room. Alarms sounded. The system shut down automatically. The aliens were horrified. Zixith started to offer condolences for the failure, but the human researchers were cheering. Excellent, Dr. Tanaka exclaimed. It failed at exactly the point our calculations predicted. This gives us critical data for the next iteration. You are celebrating a failure? Thexilon could not comprehend this. Of course. Failure teaches us more than success. Now we know what does not work. We will modify the design and try again. Thomas Edison tested thousands of filaments before he found one that worked for light bulbs. Failure is how we learn. This was incomprehensible to the concordate team. In their culture, engineering failures were shameful. Researchers who produced failed experiments were demoted or exiled. Perfection was expected. Failure was unacceptable. But humans embraced failure as part of the process. That evening, the team gathered in their hotel to discuss what they had learned. Kelath 9 spoke first. I am beginning to understand. Humans did not evolve in a stable, predictable environment. Earth is violent, chaotic, unpredictable. So humans built their technology to match their world. They design for worst-case scenarios because worst-case scenarios actually happen on Earth, Zixith added. Multiple times, regularly. Thexilon processed all the data they had gathered. The pieces were falling into place. For 200,000 years, humans made tools in survival conditions. They could not afford elegant solutions that only worked perfectly. They needed solutions that worked even when damaged, even when conditions were bad, even when everything went wrong. So they over-engineered everything, Kelath 9 concluded. Not because they wanted to, but because they had to. It became part of their culture, their education, their instinct. Arya had been listening quietly. Now she spoke. My professor used to tell a story. 2 engineers are asked to design a bridge. The concordate engineer calculates the exact forces, uses the minimum materials needed, creates an elegant structure. The human engineer calculates the same forces, then multiplies everything by a safety factor of 5, adds redundant supports, and builds it to last 1,000 years. Both bridges work, but when an earthquake hits, only one bridge survives. Before anyone could respond, an urgent communication came through. A concordate colony ship was in distress in deep space. Life support was failing. 50,000 lives were at risk. Human assistance was requested. The aliens looked at each other. Then they looked at Arya. "This is your chance," Thexelon said. "Show us what human engineering can really do." The eternal migration. Hung in the darkness of deep space like a dying giant, the colony ship stretched 3 kilometers from bow to stern, designed to carry 50,000 concordate citizens in cryogenic sleep to a new world. Now, 6 months into its journey, the ship was failing in ways its designers never anticipated. The Persistence approached carefully, Captain Santos at the helm. Beside her, Arya Chen studied the damage reports streaming in from the colony ship's systems. Behind them, the research team watched with a mixture of hope and dread. "Life support is down to 40%, Arya reported. "Main reactor is offline. Backup power can sustain critical systems for maybe 18 more hours. After that, the colonists start dying." "What happened?" Calath 9 asked the colony ship's captain over the communication link. "Micrometeor strike," Captain Velox replied, her three-eyed face showing exhaustion. "It punctured the coolant system. The cascade failure spread faster than our repair systems could contain. We followed every emergency protocol. Nothing worked." "Cascade failure," Arya repeated softly. "That is the problem with highly optimized systems. One failure triggers another, then another, until everything collapses." The Persistence docked with the colony ship. Arya led a team of 5 human engineers aboard, including Rodriguez and Jackson Pierce, who had insisted on joining the rescue mission. They carried toolkits that looked primitive compared to the sleek equipment the Concordate engineers possessed. The scene inside the colony ship was desperate. Concordate engineers stood around their diagnostic equipment watching helplessly as system after system showed red failure indicators. The ship's AI kept reporting that repairs were impossible, that components needed replacement, that the damage was beyond acceptable parameters. Rodriguez walked up to the main engineering console and studied it for 30 seconds. "Turn off the AI recommendations," he said. "But the AI has 17,000 years of engineering knowledge," protested the chief engineer. "And right now it is telling you that you are all going to die. Turn it off." Reluctantly, they complied. Rodriguez pulled out a datapad and started sketching. "Okay, here is what we are going to do. The main coolant system is fried. Can't fix it in time. So, we are not going to fix it." "Then how?" The chief engineer started. "We bypass it. Look, you have got cargo bay refrigeration units. They are designed to keep food cold, but they work by moving heat. We are going to reroute power, use those refrigeration units to cool the reactor, and run coolant through the cargo system." "That is insane," Thexelon said. "Those systems are not rated for reactor temperatures. They will fail." "Maybe," Rodriguez agreed. "But they will fail slower than doing nothing. And if we are lucky, they will last long enough to get you to the nearest station." Jackson was already at work on the power distribution system. The Concordate engineers watched in horror as he literally ripped out control panels to access the wiring beneath. He started connecting cables in ways that made the ship's schematics look like meaningless scribbles. "You are violating 17 safety protocols," one engineer warned. "Yep," Jackson said without looking up. "And saving 50,000 lives, sometimes you have got to break the rules to fix the problem." Arya led another team to the backup reactor. It had shut down automatically when the main reactor failed, following programming that said running both reactors simultaneously was dangerous. She needed to override that programming, but the ship's computer would not allow it. "Where is the manual override?" she asked. The Concordate engineers looked at each other in confusion. "There is no manual override. Why would we need one? The computer makes all decisions. Because computers can be wrong, Arya said. She turned to one of her team members. Jenkins, find the reactor control room. There has to be a physical way to start that reactor. 20 minutes later, Jenkins reported back. Found it. There is a mechanical startup sequence, but it has not been used in decades. The mechanism is stuck. Percussive maintenance, Jackson called out from across the engineering bay. What? Jenkins asked over the comm. Hit it with something heavy. Jenkins laughed. Roger that. The backup reactor rumbled to life 5 minutes later. The Concordant engineers looked shocked. Their AI had declared the reactor inoperable, but humans had simply gone around the AI and fixed the problem directly. The real challenge was the life support system. The damage was extensive. Whole sections of the ship had lost atmosphere. The oxygen recyclers were failing. The temperature regulation was gone. By Concordant standards, the ship was a total loss. Rodriguez gathered the human team for a quick conference. We cannot fix everything, but we do not need to fix everything. We just need to keep those colonists alive for 72 hours until help arrives. How? Arya asked. We create a safe zone. Seal off the damaged sections. Concentrate life support in the areas we can maintain. Use portable equipment where the built-in systems are dead. Basically, we turn this ship into a giant life raft. It was brutal work. The human engineers worked for 16 straight hours, with only brief breaks for food and water. They used duct tape, an ancient human invention that the Concordat had never developed. They used wire, spare parts, and improvised solutions that made the ship's AI scream error warnings constantly. Thexilon followed Arya through the ship, documenting everything. She watched as the young engineer fixed a critical valve using a piece of rubber, a spring from a chair, and a metal clip. It should not have worked. It worked perfectly. How did you know that would work? Thexilon asked. I did not, Arya admitted. But I had to try something. The valve needed pressure. The rubber provided a seal. The spring provided tension. The clip held it together. Sometimes you just have to improvise and hope. As the 18th hour approached, Rodriguez announced they were ready to test their repairs. Captain Velox looked at the jury-rigged systems with disbelief. Nothing looked right. Everything violated proper engineering principles. But they had no other choice. Bring the systems online, she ordered. The backup reactor kicked in, providing power. The improvised coolant system activated, using cargo refrigeration to keep the reactor from overheating. The life support systems began functioning in the sealed sections. Temperature started to stabilize. Oxygen levels held steady. It was not pretty. It was not elegant. It was not how the ship was designed to operate. But it worked. Time to failure estimate? Captain Velox asked her AI. Unable to calculate, the AI responded. Current configuration is not in any database. Systems operating outside normal parameters. Jackson laughed. That means it is confused. Good. Confused means we did something it never expected. 72 hours later, the Concordat rescue fleet arrived. They found the eternal migration limping along on backup systems held together by human ingenuity and improvisation. All 50,000 colonists were alive and safe. The rescue fleet's chief engineer spent 2 hours examining the human repairs. Then she called Rodriguez over. This should not work, she said. But it does, Rodriguez replied with a grin. How long will these repairs last? Rodriguez shrugged. Could be days, could be months, hard to say, but they will last long enough for you to get everyone to safety and do proper repairs. As the Persistence prepared to depart, Captain Velox called Captain Santos. Thank you. You saved my crew and my colonists. How can we repay you? Help us teach your people, Santos said. Share what we learned here. Sometimes the perfect solution is the enemy of the good enough solution. Sometimes you have to make things work with what you have, not what you wish you had. Thexilon stood beside Arya on the Persistence Bridge as they departed. "I understand now," she said quietly. "Human engineering is not about following rules. It is about solving problems, any way you can, with whatever you have." Arya nodded. "My grandfather used to say, 'The best plan is the one that works. Everything else is just theory.'" "We have much to learn from you," Thexilon said. "And we have much to learn from you," Arya replied. "Maybe together we can build something better than either of us could alone." The Concordat High Council chamber was a marvel of architecture and technology. Representatives from 847 species sat in perfectly arranged tiers, each position optimized for communication and visibility. Holographic displays floated in the air, showing data, images, and real-time translations. Everything was precise, elegant, and efficient. Dr. Thexilon stood at the center of it all, her crystalline form catching the light as she prepared to present her findings. Beside her, Kalath 9 and Arya Chen waited. The entire galaxy was watching this presentation through remote feeds. What they were about to hear would change everything. "Honored Council," Thexilon began, "we have completed our investigation into the human engineering paradox. After 3 months of study, hundreds of tests, and first-hand observation, we have reached a conclusion." She activated the main display. Images of human technology appeared, the crude, overbuilt, impossible devices that had started this investigation. "When we first encountered human technology, we believed it violated the laws of physics. We were wrong. Human technology follows the same physical laws as our own. The difference is not in the physics, the difference is in the philosophy." Kalath 9 stepped forward. "For 40,000 years, the Concordat has refined our engineering principles. We optimize for efficiency. We design for ideal conditions. We pursue perfection. This approach has served us well. Our technology is elegant, sophisticated, and highly advanced. But it has a weakness," Thexilon continued. "We design for the universe we wish existed. Humans design for the universe that actually exists." The display changed, showing Earth from space. Then images of its violent weather, tectonic activity, and harsh environments. Humanity evolved on what we classify as a Class 12 death world. For 200,000 years, they survived in conditions that would kill most species. Their planet attempted to destroy them with storms, earthquakes, volcanoes, ice ages, droughts, and countless other disasters. They could not afford elegant solutions, Kalath 9 explained. They could not build technology that only worked under perfect conditions. They needed tools that worked when everything went wrong, because on Earth, things went wrong constantly. Arya spoke for the first time, her voice steady despite addressing the most powerful beings in the galaxy. "We have a saying, Murphy's Law. If something can go wrong, it will go wrong, at the worst possible time." In the worst possible way, every human engineer learns this principle. We do not design for success. We design for survival. The display showed comparison after comparison. Concordat systems versus human systems. In ideal conditions, Concordat technology was superior in every measurable way. But when conditions became difficult, when damage occurred, when the unexpected happened, human technology kept working. "Let me illustrate with a specific example," Thexilon said. The display showed the Eternal Migration Rescue. This colony ship was dying. Our engineers, using our advanced technology and sophisticated AI systems, could not save it. The damage was beyond acceptable parameters. "But humans saved it," Kalath 9 continued, "using improvisation, redundancy, and over-engineering. They did not fix the ship properly. They made it work with whatever they had available. This approach seems primitive, but it saved 50,000 lives." A murmur ran through the council chamber. The rescue had been galactic news. Everyone knew humans had saved the ship, but few understood how or why. The key difference, Thexilon explained, is in how our species think about failure. In concordate culture, failure is shameful. We design perfect systems. When they fail, we replace them. Humans expect failure. They design redundant systems. When something fails, they repair it, bypass it, or work around it. She brought up images from the human manufacturing facilities, the violent, chaotic processes that had shocked the research team. Humans have a concept called percussive maintenance. They literally hit broken equipment until it works again. This seems absurd, but it reflects a deeper truth. Human technology is robust enough to survive being hit. Our technology is not. The display changed again, showing code comparisons. Human programming is inefficient by our standards. It is 3 times longer than necessary. It contains redundant error checking. It assumes components will fail and plans for it. Our programming is elegant and optimized. But when a single error occurs, our programs crash. Human programs detect the error and continue functioning. We have spent 40,000 years perfecting our technology, Kelath 9 said. Humans spent 200,000 years breaking their technology and fixing it again. We learned to prevent problems. They learned to solve problems. An elder council member, a being of pure energy named Luminex, spoke. Are you suggesting our engineering is inferior? No, Thexilon replied carefully. I am suggesting our engineering is different. Concordate technology excels in controlled, optimal conditions. Human technology excels in chaos and adversity. Both approaches have value. She paused, letting that sink in. But the universe is not always controlled or optimal. The universe is chaotic, and in chaos, human engineering has proven more reliable. Another council member stood. This seems to suggest we should abandon our engineering principles. Not at all, Arya interjected. Your engineering is amazing. Your precision, your efficiency, your elegance. These are all valuable. What we are suggesting is synthesis. Combine concordate precision with human reliability. Build systems that are both sophisticated and robust. Thexilon nodded. We propose a joint technology initiative, humans and concordate engineers working together, creating systems that benefit from both philosophies. The display showed mock-ups of hybrid designs, ships with concordate elegance and human redundancy, computers with optimized code and robust error handling, reactors with precise control and fail-safe backups. Imagine a ship, Kelath 9 said, that has the efficiency of concordate propulsion, but the reliability of human over-engineering. A vessel that performs optimally under normal conditions, but survives when conditions are abnormal. That is the future we propose, Thexilon concluded. Not human technology replacing ours, or our technology replacing theirs, but both working together, creating something better than either could achieve alone. The council chamber was silent. 847 species processing this information. Finally, Luminex spoke again. You have given us much to consider, Dr. Thexilon. The council will deliberate on your recommendations. The presentation ended, but the impact was immediate. Within hours, universities across the Concordate were requesting human engineering consultants. Research institutions wanted to study human problem-solving methods. Manufacturers wanted to incorporate redundancy into their designs. 3 weeks later, Arya received an offer she never expected, a position as professor at Concordate Central University teaching a new course, Applied Chaos Engineering. The course description made her laugh. Teaching Concordate engineers to think like humans, designing for Murphy's Law. She accepted. 6 months after that, the Joint Shipbuilding Initiative produced its first vessel, the Harmony's Forge. It was beautiful, combining the sleek lines of Concordat design with the robust structure of human engineering. It had Concordat-level efficiency with human-level reliability. It could operate in conditions that would destroy any previous ship. Captain Santos and Kelath 9 stood on its bridge for the maiden voyage. The ship hummed with power, all systems showing green. Strange to think, Keleth 9 mused, that we believed ourselves the pinnacle of engineering. Then we met humans and learned we had only mastered half the equation. Santos smiled. You had mastered perfection. We had mastered imperfection. Turns out the universe needs both. Your species has a saying, Keleth 9 said, about standing on the shoulders of giants. We see further by standing on the shoulders of those who came before us, Santos quoted. Perhaps now, Keleth 9 replied, we all stand together. Concordant precision and human resilience, supporting each other, seeing further than any of us could alone. The Harmony's forge engaged its engines and leapt into faster-than-light travel. Behind it, across the galaxy, thousands of engineers from hundreds of species were learning a new way to think. They were learning that optimal was not always best, that elegant was not always reliable, that sometimes the perfect solution was the enemy of the working solution. They were learning that in a chaotic universe, over-engineering was not a flaw. It was wisdom. Arya Chen taught her first class that same week. 50 concordant students, the brightest minds of their generation, sat before her with uncertainty. They had spent their lives learning to design perfect systems. Now a human was going to teach them to design imperfect ones. Welcome, Arya began, to Applied Chaos Engineering. In this course, you will learn the most important rule of human engineering. Write this down. Assume everything will fail. The students looked shocked. One raised a tentacle. But proper design prevents failure. Arya smiled. Proper design delays failure. Nothing prevents it forever. So we design knowing failure will come. We plan for it. We prepare for it. We make sure that when it happens, and it will happen, our systems survive anyway. She held up a simple wrench, the same tool Jackson Pierce had shown to the research team months ago. This tool is 2,000 years old in design. It will work for another 2,000 years, not because it is perfect, but because it is simple, robust, and reliable. That is what we are going to learn. How to build things that last. How to create technology that survives the universe as it actually is, not as we wish it to be. The class began, and with it, a new era of galactic engineering was born. An era where the galaxy's smartest finally understood that sometimes the crude solution was the correct one. Where over-engineering was not waste, but wisdom. Where redundancy was not inefficiency, but survival. An era where humans and aliens built the future together, one improvised solution at a time.